0 equals 0. Is this a true statement? Yes. Therefore, there are an infinite number of solutions. I know how much you guys like my writing, so there we have it. Finest sample of handwriting I can offer. There are an infinite number of solutions, which means that these lines are collinear, meaning that these lines lie directly on top of each other. There are an infinite number of solutions, infinite number of intersections. Okay, let's keep on trucking. Number 12. How are we doing here? Okay, good. We're almost finished. Number 12. A car dealership is offering interest-free car loans for 1 day only. During this day, a salesperson at the dealership sells 2 cars. Okay. One of his clients decides to pay off his $17,424 car in 36 monthly payments of $484. His other client decides to pay off his $15,840 car in 48 monthly payments of $330. Which system can be used to determine the number of X months after which both clients will have the same loan balance of Y? Okay. So what we want to determine here is so it looks like that all of our answers here are expressed in terms of a system where Y is isolated. And so we know that our loan balance is Y. So our loan balance, Y, so let's make a little note here. Y equals the loan balance. And the X equals the months. So as the months go by, the clients are making payments on their loan, and therefore their loan balance goes down. So let's look at this first situation for client number 1. His first client pays off his $17,000 loan in 36 monthly payments of $484. So every month X, he makes a payment of $484, and that decreases the amount of his loan. So what we need to do is that we need to be very careful and make sure that what we write communicates the fact that his loan balance decreases every time he makes a payment. So I'm going to write a negative 484 times X plus 17,424. So every month he takes away 484 from this loan balance. Now let's look at the other client. He pays off his $15,840 balance with monthly payments of 330X. And if you want to think about it, these are cash flows out. So that's another way that you can realize that that's a negative sign, representing that this is a negative cash flow for the client. If that helps you, great. If not, please forget it. So here's our system, which looks like it's answer B. Hopefully that was a clear exposition of number 12. Please be sure to come and see me in the morning if that wasn't a clear exposition. It's a little bit tough to communicate these concepts over the microphone in one fell swoop. So the key concept here was to realize that Y was the loan balance, and our loan balance was a function of X, which was the number of months that went by. Every month, a certain payment is made to decrease the value of the loan. All right, number 13. Now, here's what I really want you guys to keep in mind for 13 and 14. When you're given a word problem, and it's a systems, when you're given a word problem, and it's a systems word problem, you're going to use only either one of two methods. Method 1 is you're going to use the elimination method. So if you're going to use the elimination method, there's a protocol you need to follow. If you're going to use the substitution method, that's the second method, there's also a protocol you need to follow. So as you're reading the word problem, be thinking to yourself, do I need to set up my system using an elimination or a substitution? Number 13, we need to use an elimination. And the reason you can tell is because you're given total amounts and you're given rates of change. That's how you know that you need to set up a word problem using an elimination format, when you're given total amounts and rates of change. Let's now take that idea and apply it to 13. Okay, so 13, kirigami is the Japanese art of making paper designs by folding and cutting paper. A student sells small and large. Okay, here we go. We're starting to get into our variables here. Oh, get off of here, dang it. A student is selling a small and large greeting cards decorated with origami or kirigami at a craft fair. The small cards cost $3 per card. Per card. That's a rate. That's a rate of change. And the large cards cost $5 per card. There's another rate. The student collects a total of $95 for selling a total of 25 cards. So notice we have two rates and two totals. So here's what we do. First, find the total amounts. Or no, actually, let's back up and figure out what are we trying to find. How many of each type of card did the student sell? Well, what types are there? There's the small card and there's the large card. So that's what we don't know. That's what we're trying to figure out. Therefore, those are our variables. So we need to define our variables. Let x equal number of small cards. Let y equal number of large cards. Okay, so there are our variables. Now let's set up our equation. First, find the total amounts. Oh, I see. There are the total amounts, 95 and 25. Good. Immediately take those and put them in your system. Like this, 95 equals 25 equals. Okay, good. Now let's work on this 95, or let's work on this 25 here. This is 25 what? Oh, it's 25 cards, Mr. Russell. Okay, you're right, it's 25 cards. What type of cards do we have? Well, we have small and large cards. What variable represents? So what you're telling me is that we only have small and large cards, and that the sum, the total of those cards is 25? Yes, that's exactly what I'm saying, Mr. Russell. Good. So what that means is that since x represents the number of small cards we have, and y represents the number of large cards we have, x plus y is going to equal 25, which is the total number of cards we have. So there's our first system. Now let's write our second system. They made 95 bucks. Okay, so x plus y. They made $3 per small card. So there's a rate, $3 per small card. And they made $5 per large card. So there's our second rate. It goes in front of y. So look, isn't $3 times the number of small cards we have plus $5 times the number of large cards we have equal to the total amount they made, 95? Yeah, so there's our system. So let's solve it. 95 equals 3x plus 5y. 25 equals x plus y. I'm going to eliminate the x's. I'm going to multiply this equation by negative 3. So let's rewrite this. I'll rewrite it over here. 95 equals 3x plus 5y. Negative 75 equals